I'm right in the middle of finishing up a bunch of new projects and making a big upgrade on my Onefinity to the Elite series. But I wanted to take a minute and drop this video, which is a compilation of some of my best tips, tricks, and techniques to get better results out of your CNC work. Now, this is a longer video, so I've put several chapter markers down in the bottom so that if you want to skip around and see what each one's about, you can easily do that. As always, thanks for your support for this channel. Take a look at the topics down in the description and have fun CNCing. Have you ever seen a shiny new tool review and immediately hit that buy now button only to be hit with a case of buyer's remorse a month down the road? You see sponsored YouTube videos of tool unboxings all the time, and they look great right out of the box, but how do they hold up over time? Are they really worth it? I bought this Onefinity CNC in the summer of 22, and after just over a year of use, I'm going to tell you the good, the bad, and the ugly of using this type of equipment, as well as showing you how the Onefinity specifically has held up and where it's fallen short after just over 1 year of use. Hi, my name is Damien with Southpaw Designs, and this is an unsponsored and unbiased review of my CNC experience in general, as well as my Onefinity specifically after just over 1 year of use. So let's start by talking about the positives of using a CNC in general. For you folks that are just now starting out and trying to figure out how to afford an entire workshop, here's a key perk that I've just fully started to realize. In a pinch, a CNC machine can actually replace other types of tools, such as a jointer, planer, drill press, router table, and others. Need to plane boards that are wider than 13 inches, and all you have is the 13-inch DeWalt 735? Look no further. All you need is a CNC machine and a surfacing bit. Also, do you know a CNC can give you a perfect straight edge, making a jointer unnecessary for small projects. In the past, I've used a table saw, sled, or track saw for jointing my small projects, but I've come to realize that my CNC does a great job with it. Now, that doesn't mean that you'll never need equipment such as a planer, jointer, or a drill press, but if you're just now building your shop and you don't have the money for every tool that you need, consider that a CNC can handle many of those tasks in the short term. Next, CNC allows you to create custom work, engravings, inlays, and I've actually collaborated with several other woodworkers in my area who need CNC work done for their own customers' projects. So while they specialize and may be more experienced in more traditional types of woodworking, my CNC experience has become very invaluable to them. CNC work actually can open up new markets that you might not have considered. I've recently found an entirely new market in my area for making plaques and personalized gifts for high school booster clubs for their senior honors. This is a great way to sell 5, 10, 20 copies of a project at once, and can be a great moneymaker when you're just starting out. It also allows you to be creative and artistic. I've designed so many unique projects that you can't find anywhere else. And the most common conversation that I'm having with friends and coworkers when I walk into work every morning is, "Hey, I saw that last project on Facebook. What are you working on now? I can't wait to see it." And for those of you that are money conscious, did you ever think about the fact that your CNC can make cleaning up your shop profitable? How so? Think about this. While I'm cleaning up at the end of a day, sweeping my floors, putting my tools away, my CNC is running and finishing up projects that I've started that day while I'm actually in the cleanup process. When I'm done, I just simply turn off my CNC, my shop is clean, and I'm ready to enjoy my evening. Now, let's talk about the drawbacks of a CNC in general. This particular model right here sold for about $2,400 a year and a half ago. Onefinity has since come out with new models and new styles that are even more expensive, so it's not cheap to get into. But in addition to the cost of just buying your CNC, there are so many other things that you have to consider. First, you're going to need a trim router or a spindle. A trim router, the Makita that I use right here, costs about $188 on Amazon. It's actually currently on sale as of the time of this filming for about 34% off, but that's in addition to the cost of the CNC itself. You can upgrade to a spindle, which is recommended for those who are planning on doing more elaborate projects, but that comes at an additional cost as well. Next, you're going to need a touch probe. The particular touch probe that I have costs $92.63, so it's not cheap. Then you're going to have a wide variety of bits, running anywhere from $15 to $50 or more. You're going to need a variety of end mill, ball nose, surfacing bits, bowl bits, possibly compression bits as well. And they're not cheap. And they do break and wear out over time, so you're going to have to replace those. Next, you're going to need to consider dust collection. This particular model has a dust collection kit that is sold by Onefinity at a cost of about $150. Then you're going to need hold down clamps, tape, a spoil board, and you're going to have to build an enclosure. And all of those things cost money. And then finally, probably the biggest additional expense that you're going to have is you're going to have to buy some type of software to design your projects. I use Vectric's VCarve Pro, which I highly recommend, but it comes at a price of $699. Next, you will need to buy or build a table, and I recommend an enclosure. I currently don't have an enclosure for my CNC, but I'm planning on building one in hopes that that will cut down on the amount of dust that's spilled into the air and cut down on the noise produced. Next, the footprint is relatively large. Drew Fisher has a great video on making a mobile assembly table that doubles as a CNC table that actually folds up and rolls away. I'll put a link to that down in the description because it's a great video. But overall, you're going to need probably at least 16 square feet. This particular model with the table built is about 4 by 4. And next, you're going to get less hands-on than you do with traditional woodworking tools and processes. CNC woodworking is still woodworking, no matter what some of the traditional woodworkers say, because you must still mill, cut, sand, and finish your work. And in many situations, using your CNC is just one tool to add one feature to a traditional woodworking project. Now, if you happen to disagree with that, let me know why down in the comments. All right, next. So let's talk about the Onefinity in particular. I actually did a product review of this just over a year ago at about the 3-month mark. And so if you'd like to take a look at that, I'll put it up in the card right, I believe it's right here, as well as in the description down below. I might hit on a couple of points from that original review, but in general, I'm going to talk about how it's held up over a year. First, just to hit on a few of those major points. It does have a lead screw design, doesn't have any belt drives, which from everything that I understand, and I'm not an expert on the engineering of it, it means more stable construction and is generally for the purposes of what we're using a CNC for, especially a hobbyist model, tends to be a better option than using belts. Next, regarding the Onefinity in general, it's well constructed. The general structure is rock solid. So in terms of construction and quality, I give it a total thumbs up. Hey, and while we're talking about thumbs up, don't forget to hit that like button down below. Yes, nailed that one. That was a perfect call to action. You didn't even see it coming, so you got to give me that like down below. Next, after 15 months, this Onefinity CNC is still going strong, but there are some minor issues which we'll talk about in just a minute. Most of the issues that I've run into have to do with general wear and tear and replaceable items that you would kind of expect to happen, or some minor maintenance issues that I have to deal with. So let's go ahead and talk about that. If you've watched the 3-month review, I stated a year ago that the monitor that I bought from Onefinity was kind of cheap. In recent months, the monitor started flickering out with the least little touch on the cables, or if the table shifted or vibrated at all. So I assumed that the cable was going bad. After checking the cable and finding out that it was actually fine, my fear was that the HDMI port on the back of the control box would be going out, because at any wiggle or touch on that HDMI port, the video would cut out. Thankfully, being a child of the 80s, I tried the old Nintendo solution and just unplugged it and blew into that HDMI port, and it just turned out that there was a little buildup of sawdust in there, and since then, it's been great. It's not cut out once. Next, I have run into a couple of issues with loose bolts, but realistically, this just comes down to routine maintenance.
Screws fall out all the time. The world's an imperfect place.
The one on the back of my Z-axis actually came loose enough that it snagged the router mount as it was dropping and prevented the router from fully going to a proper depth, which caused me a problem that I had to fix. Again, this simply comes down to routine maintenance, so make sure to check out your screws and tighten anything that may be loose. Even if it's not loose, it never hurts to hit it with an Allen wrench. Next, the dust boot that's sold by Onefinity is held in place by magnets, which is actually kind of handy. But a couple of times, ever so often, it's come loose and it's hit the router bit, causing some very unpleasant noises.
Want to hear the most annoying sound in the world?
As you can see right here, it's about time to replace it because pieces have broken off, and I've tried to replace that shroud with just a simple piece of cardboard. The dust boot itself that's sold by Onefinity only costs about 18 bucks, so it's not a big deal to replace that. Now, here is the big problem that I've had specifically with my Onefinity. Occasionally, and without reason, the X or Y axis has been known to randomly shift. It will complete one pass just fine, but when it moves to pass number 2, it's shifted over by a couple of inches. As soon as it goes deeper, all of a sudden, it ruins your project. Now, anytime that it's happened, it's not been the result of me hitting my CNC, an electrical disturbance, or anything like that. It's, in my opinion, just happened randomly and without reason. Now, I can say that over the course of 15 months, I've really only noticed it happening 3 or 4 times. Most recently in this project right here. But overall, that's really the only problem that I can think of with this CNC machine that can't be chalked up to normal wear and tear or routine maintenance. So, what are my takeaways from this past 15 months? First of all, I wouldn't trade the value of a CNC in my shop for anything. Now, CNC isn't for everyone. It requires an understanding of basic computer-aided design. It requires a good understanding of software and how to use a computer in general. So if you're an old school woodworker or you don't have good computer skills, it's going to be a tougher learning curve for you. And if you enjoy the aspects of traditional woodworking, some of that is removed because the CNC will do some of the work for you. But because of my CNC, me as a humble high school computer science and multimedia teacher, I've been able to go from just being that to somebody who's known by my colleagues and friends and even the community around as a competent woodworker and creator, which I love. Now, how about the Onefinity brand specifically, as opposed to Shapeco, Carve, or some other brand? Over the course of the last 15 months, this machine has held up like a champ. Aside from a couple of glitches and minor technical issues that arise from time to time with any type of computer-related machinery, as well as general wear and tear, this CNC has been very reliable. Now, I hope you've gotten some valuable information out of this video, and if so, I'd appreciate it if you hit that subscribe button below. And if you're interested in learning more about some awesome CNC projects that you can create on your own, that's what I enjoy doing more than anything else. So please subscribe and check out the playlist and videos that I have linked below, as well as the video right here. So you did it. You decided to purchase your very first CNC system, or maybe you haven't made the decision yet, but you're weighing the pros and cons of it. So let's go ahead and talk a little bit about the hidden costs of building and setting up your first CNC system so you can really understand what you're getting into. Now, first off, I use the Onefinity Woodworker X50, which is a 32 by 32 CNC machine, and it's on the high end of the hobbyist machines. It's been a great machine for me. I really like it. I have a review of it that I'll put up in the card right up here and then also in the description down below. Now, also keep in mind, depending on the version or type of CNC that you buy, some of the things that I'll mention may or may not come with it. For example, with my Onefinity, it did not actually come with the router itself. I had to buy that separate. This is a Makita Palm router that Onefinity recommended. Also, didn't come with the touchscreen. I had to buy that separate. And you can get it with or without the computer module. I chose to go ahead and get it myself. Now, before we go any further, I've told you guys on multiple occasions, I don't like shilling products or anything like that. But this particular video is about the products that you would need to use with a CNC. And I've said it only makes sense that if I'm using a product, it's a good idea to put the link down in the description just so you can find it yourself. And if I'm going to put the link in the description, why not go ahead and make 2% off of it, 3% off of it, if it's something that I use myself. So I am going to mention some products today that I do use, and they will be in the description. Now, if you do choose to buy any of them, I'd appreciate it if you'd actually click on the links and go through there, because as an Amazon affiliate, I do get a little kickback from any purchases that are made through those links. Those are items that most people need to understand are integral to running your CNC, but may or may not actually come with it. But I want to spend the majority of the time talking about those things that you might not think about that you need in order to run your CNC machine. First off is a touch probe. Now, I have a separate video where I talk about how a touch probe is actually used. Basically, this is used to find the X, Y, and Z of your workpiece so that when you load your program, it knows exactly where the wood is and where to start cutting. It's the origin point. I've heard some CNC users say that they don't have one and they'll just eyeball it, and that's great. That's fine if that's what you'd like to do. I prefer having a touch probe because it allows me to precisely find the X, Y, and Z. That comes in handy, especially when you're going to be doing tool changes and you have projects that require a variety of different tools. Maybe you're going from a V-bit to an end mill. You'd need to be able to go back to your origin point and know the X, Y, and Z point. Now, the one that I bought was sold by Onefinity, but there are third-party touch probes that you can buy off Amazon and things like that. I'll put a couple links down in the description. And before we go any further, I am an Amazon affiliate. I'm not affiliated with any companies. So if I put a link down in the description, please know that I will get a small percentage if you choose to buy a product through that link. But I'm not affiliated with any companies, so I don't necessarily have a preference other than that's what I happen to use. So let's talk about dust collection. The CNC is just like any other woodworking tool where sawdust is going to be created. And because of the fact that many times you're going to be boring out pockets, you can create a lot more sawdust with a CNC than with other types of woodworking tools. Now, that's generally not as big of a deal because most of the sawdust created is going to be restricted to the area where your bit is cutting. So as long as you have a good vacuum seal right there, you can limit the amount of sawdust. Now, regarding this sawdust, I recently filmed a video and I wanted my viewers to be able to actually see the cut, so I didn't attach a dust boot. So most of the dust created is actually right here. Now, for my needs, I just use this DeWalt shop vac as well as a bucket that I picked up from my home center and this cyclone system that is great at separating the sawdust, so it puts much less stress on the filter of your shop vac. Now, I use this 2.5-inch hose, which connects into the dust boot, which attaches to my CNC. The CNC that I bought, which is the Onefinity Woodworker X50, didn't come with that dust boot, so that was an additional cost. So this is something that you will need to consider. You may already have a shop vac or some type of dust collection system. Just keep that in mind. Oh wow, it got cleaned up. Now that we have this out of the way, let's talk about CNC bits. Now, first of all, a couple of these are bits that aren't necessarily associated with my CNC. I just kind of keep them on this handy dandy little French cleat that I've built for my CNC. For example, this one right here, this is a dado bit that would typically go in a conventional router. I just have it with these. Also, we have a keyhole bit. This is useful for putting keyholes on the back of your work so you can mount it on a wall. Not necessarily something that I use with the CNC, although you can automate that process with a simple tool path. I have a few bowl bits. These are handy when you're creating bowls, plates, that kind of thing. Good for hogging out a lot of material. These are definitely good bits to have. Next, we have a surfacing bit. This is good for flattening out material, and it's great on a CNC, especially if you don't have a planer and a jointer. You can actually flatten your material on your CNC so you can get a nice flat surface. Next, we're going to have your upcut and downcut bits. This is an upcut bit, which actually pulls the material up, giving you a rougher top surface, but a more precise bottom surface. And I have a variety of different size V-bits. These are great for engraving, and they're always handy to have a couple. It turns out I actually don't use the 20-degree bit as much as I thought that I would, but I do use this 90-degree and this 60-degree quite a bit. Next, these are my 1/4-inch bits. These are worth their weight in gold. On the left, you will see that is the upcut bit. On the right, that's the downcut bit. And the 1/4-inch bits are handy because they can do a lot of work in a shorter period of time. So these are definitely bits that I recommend that you have. All right, so now let's talk about all the little accessories and things that you're probably going to have to get at some point. Number one, how are you actually going to hold your material, your wood, your acrylic, your plastic, aluminum maybe? How are you going to hold that down to your work surface? Again, this will vary depending on the type of CNC machine that you buy, but if you're using one like I have, which basically just has the CNC setup, not only are you going to have to decide how you want to set up your spoil board, you're going to have to figure out how you're going to hold your material to that spoil board. So the method that I commonly use is blue tape along with CA glue and activator. Now this is actually a 4-pack that I bought recently. I'm going to link this down in the description below, because if you use CA glue in your shop, this is actually a really good deal. I find of all the links that I put down in my description, this is probably the most popular item that people like. What this does is this allows you to tape both the surface as well as your workpiece, then use CA glue and activator to spray it and then press it down. If you do this, then many times there's not any need to have any additional clamps or anything like that. Next, you have a variety of different types of clamps. I actually used these clamps in a recent project, and as you can see here, that was a mistake. I'll put a link in the description below where you can actually see that project being built and how I messed up and actually ran across this clamp right here and almost damaged my bit or my CNC. And then you may just choose, as I have done recently, to simply screw your material down to your spoil board. Now, the downside of that is you will chew up your spoil board eventually, but that's why they call it spoil board or waste board. It is the type of thing that you are going to need to replace every once in a while. Next, get a good set of calipers. These are cheap, but they do the job. I'm not machining engine parts or anything like that. So as long as I can get fairly accurate results, then this caliper is good enough for me. And then we have Oramask. Oramask is a material, it's like a thick tape that you cover your workpiece with so that once your CNC is done actually cutting out the design, the cut portion is exposed, and so you can paint that. Then you peel the Oramask away and you have either the original color or the original wood grain without the need to do much sanding on your project. So Oramask is very handy. Now, I'm not great with Oramask. I've only used it in a couple of projects, so it's something that I still need to practice on, but I've seen several folks on YouTube who use Oramask religiously, and they do a great job with it. Now, let's take a minute and talk about how you're actually going to fit your CNC into your shop. Depending on the CNC, the model that you buy, it may actually come with a table. It may actually come with a frame or a spoil board. The Onefinity that I bought did not. It was just the rails, and I had to build everything myself. Now, I chose to build my own table out of 3/4 inch plywood that is 4 feet by 4 feet, as well as 3/4 inch MDF board as my spoil board with T-track so that I could use clamps to actually hold my material down. Now, another thing to consider is how you're actually going to move and control your CNC. I simply use the touchscreen right here, but a lot of folks, in fact, probably more online on YouTube, use a remote control. Okay, I don't actually have a remote control. You might be saying, but Damien, you have a remote control in your hand. This is an Xbox controller. I may be able to plug it up. I'm not sure. I've never tried, but I do have an Xbox. But this is what they look like, all right? I'm not gonna put a link in the description for any of these controllers because I've never used them, so I don't wanna put a link to something that I've never used. But you may want to get a remote control to jog your CNC. Now, remember when I said I'm not gonna mention anything that you'd already have in your shop? I am gonna talk about a drill, but more specifically, these sanding discs. I found these on Amazon, and these have been a lifesaver. These are great because they're good for sanding in small areas, and I found them to be very handy getting into the small areas that you might actually create a pocket for with your CNC. So these are actually really handy. And this particular package that I bought goes anywhere from, I want to say 120 up to 2000 grit. So they have a variety of different sizes and several of them in here. Now, another thing that I really like about this is that if you needed to get into some small intricate areas and you just wanted to hand sand, these little discs are great. You can just fold them in half and then use them to really kind of get in those nooks and crannies. And I will put those in the description as well. Oh, when you're trying to record, but the shop doggies just need a little loving. And finally, how are you going to design your work? Oh, sorry. When you're designing your work, you're going to need some type of software. Now, you can just go out on places like Etsy or southpawdesigns.com, and you can download some files for projects. But what if you wanted to actually create your own? You're going to need some type of design software. Now, I prefer to use VCarve Pro myself. It's just the one that I like the best. I do have a review where I talk about 3 of the major ones, and I'll link that in the description below and in the card, whichever side right is, I don't know. But you'll need some type of software yourself. The 3 main ones that you'll find are Easel, which is an online software. It's probably the cheapest, but it's a fairly simplified version, very easy to learn, but you're somewhat limited in what you can do. Then you have kind of the mid-range that I think is good for a CNC woodworker, and that's VCarve Pro. You have to have a little bit better knowledge of how computers work and how to design in a 3D environment, but it's fairly easy for the average person to learn. And then you have Fusion 360, which I believe is much more advanced. In my opinion, Fusion 360 is more for fabrication and more engineering and CAD CAM type applications, although you can use it for CNC itself. And again, there's a review of all 3 of those in the description below if you'd like to check those out. Then, of course, there are a variety of other items that you might need to have: finishes, paints, sealers, saws. But again, I don't want to go through the time to talk about all the things that you might already have in your shop. We're mainly talking about the things that you might not think that you would need to get up and running with your CNC. So I hope you enjoyed it, and please hit that subscribe button below. That really helps to grow this channel, and leave a like and a comment. Tell me what things I left off, or things that you as a CNC owner find that you need in your shop that maybe I didn't go over. Hey folks, Damien with Southpaw Designs, and I've been gone for a few weeks. School started back, so my priorities have been at school, getting those kiddos started back, and it started off to be a great year. But now we're back in the shop, and we're trying something new. We're going back to basics, and I'm trying to improve my technique when it comes to painting and sealing V-carve inlays. So what we're going to do is we're going to try our hand with 3 different types of sealants to see which one actually holds up the best. The first one we're going to use is shellac. The second one is going to be lacquer. And the third one is going to be epoxy. Now, I'm not really a fan of trying to use epoxy just as a seal coat, but I read a couple articles saying it was a possibility, so I thought I'd give it a shot. So let's dig right in. To begin with, in an effort to appear all sciencey, I'm going to make a control group, which is just going to be MDF, pine, and white oak, but I'm going to write control on it so it seems like I know what I'm talking about. Then we're going to try a second option with shellac, a third with lacquer, and the fourth one at the very top is simply going to be epoxy. Next, I'm going to use 2 coats of shellac and lacquer. I'm going to go ahead and seal these up. Now, these paper towels will prevent any shellac from getting on the lacquer or the control section. This is how certain bio labs prevent diseases from getting out to the public, and it works great. Next, let's go ahead and do some lacquer. Same method. I'm actually going to do a total of 2 coats, which I think will give it a little bit better of a seal there. And next, we're going to move on to epoxy. I'm just using a little rubber thing, I think that's the technical term, to spread it out. It ends up being a little thicker than I would like it to be for being a seal coat, but it's still a good experiment. I'm not worried about getting rid of the drips on the sides, because all I'm really concerned about is to see how it actually seals. We'll use a little torch to get any bubbles out there and try to flatten it out a little bit, and then let everything set up overnight to dry. Once everything's had a chance to dry, I'll apply some Oramask. Oramask is a great protectant. It covers the material, so the CNC will cut through the Oramask and Once it's finished, all that will be exposed will be the part that's actually been cut, which is going to be my engraving. I've left a link down in the description below, so if you need to get any aura mask, you can check it out right there. Now, I didn't sand it, and I did clean it off pretty well, but I didn't sand it. So I feel like that aura mask might not have stuck as tight in a few spots, as you'll see later on, but it still did a pretty good job. Hey, if you haven't done so, I'd appreciate it if you go down, hit that like button, hit that subscribe button, leave a comment if you like, because those analytics and those interactions tell YouTube that this is valuable content. It doesn't cost you a penny, and it helps me to get this content out to a broader audience, which makes it worthwhile on my end. All right, once we have everything in place, now we're simply going to cut out the letter M over and over and over again. Don't ask me why I chose the letter M. I believe it was just a cool letter that has a lot of flares and changes in direction. So I thought it would give us a good finish so that we can really experiment by painting inside of it. Now that the engraving is done, I'm going to use a fine point brush to put a seal coat inside of that epoxy section. That should give us a nice seal so that we can go back later on and paint it and hopefully get a nice seal coat so there's no bleed. Following that, we'll do the same thing with the lacquer and shellac. Now in hindsight, I think it would have been better if I would have used 2 coats of lacquer and shellac because we do end up with a little bit of bleed that I wonder if that would have been prevented if I'd had 2 coats in there. Next, it's time to paint. I'm just going to try to spray paint it because I've got it handy. It's readily available, and there are a variety of colors. I'm going to use some gloss black Krylon Fusion all-in-one paint and primer. If anybody has any suggestions of a recommended type of paint to use for this, please let me know because I'm still learning the painting side of things. Once it's painted, we simply let it dry. And then let's start peeling. I start off with the pine. Why? I don't know. I just did. And as we can see with the control group, there's definitely quite a bit of bleeding in there. And that's to be expected. Now let's move on to the white oak. You see a little bit of bleeding, but it's just on top. Hopefully we can sand that off. And then let's move on to the MDF, which, yep, as we figured, with no type of seal there at all, there's quite a bit of bleed. MDF is basically just compressed sawdust, so we thought we would see that. All right, now let's move on to the shellac and peel this off. What I did find was the paint tended to flake off and get on the wood, so you got to be careful of that. We do see with the shellac a little bit of bleeding on the pine. Now let's move on to the lacquer. The lacquer seems to have done a pretty good job. There's a little bit of bleed, but not much. And then we move on to the epoxy, and it's what I thought would happen. It's a great finish. In fact, I really like it. I wasn't a fan of actually using epoxy as a sealer, but you know what? It looks gorgeous. It's expensive, it's messy, but you can't really argue with the results. Now, again, you do see a little bit of grittiness in there. That's because I didn't sand it down to a fine finish because that wasn't the point of this particular exercise. Now let's move to the white oak, and we are going to find that with the shellac, there's a little bit of bleed, not much, and hopefully that's on top of the shellac so I can sand that off here in just a minute. Next, we'll move to the lacquer, and the lacquer gave us a really good finish. You can actually see at the top of the M right there that a little bit of the flakiness flaked onto the wood, so I'll have to address that. And now let's move on to the epoxy. The epoxy, just like I thought, would be clean and beautiful. And so finally, let's move on to the MDF. Okay, with the shellac, the MDF left quite a bit of bleed right there. Now again, that could still be on top of the shellac, so if I sand it off, it could come up. We get a similar result with the lacquer. And this could be because the edges kind of crept up a little bit and they didn't stick to the material. So that could be my fault. And then once again with the epoxy, actually with the epoxy, we get a really cool finish on the MDF board. This may be my go-to when I'm seal coating MDF. Okay, once we've had a chance to take off all of the aura mask, we will sand everything down and see what it really looks like. Use the blower to blow out any material that happens to be inside of there. Now let's take a look. All right, so what's my takeaway here? With the MDF board, of course, we knew that it was going to be harder to seal. Had I actually put another coat of shellac or lacquer inside that V-cut, it could have done a better job. You'll also notice that the epoxy really darkens that MDF because it really soaks in. So you got to remember that, although you'd probably be painting the surface of the MDF as well. With the softwood, with the pine, we did see that even with a single coat of shellac inside of the V-carve, that it still has a little bit of bleed, but I feel like the lacquer did a much better job. And then of course the epoxy did a great job. It's a very thick seal, but I don't know if I want to do an epoxy seal, as I've already said. And then finally, with the hardwood, all the results are pretty good. Even with only the aura mask, we have very little bleed through, but we do have a little bit. Did an excellent job with both the shellac and the lacquer, and then also with the epoxy. So for hardwood, for me personally, I think that my go-to is going to be shellac, just because I like using shellac over lacquer because it's natural, it smells a little bit nicer, and I just like going that direction. For softwoods, in this case, it actually looks like the lacquer turned out better, but I may try this experiment again with 2 coats of sealant inside to see if that does a better job of preventing that bleed with that pine. And as always, thank you for watching to the end. And remember, if you haven't done so already, hit that like button, leave a comment, hit that subscribe button if you haven't, because those metrics really tell YouTube that this is valuable content, and it strokes that algorithm. And it helps me to get it out there to a wider audience and build this channel at no cost to you. So thank you for everything. Thank you for being part of the Southpaw Nation, whatever. Okay, so there you go. Hope you got something out of it. Let me know in the comments which method you like to use, or if I did anything wrong, what you would do different. Because as I keep telling you guys, I'm learning as I go. I'm constantly learning new techniques, and I'm getting better every time. So if you haven't hit that like button, do so. Leave a comment. Hit that subscribe button if you haven't, because those metrics cost you nothing, but they help me to build this channel and make it worthwhile to put this content out there. So let's get out there and build stuff. Well, I finally did it. With this business and channel growing by leaps and bounds, I'm finding that this machine here is bringing in a lot of income and getting a lot of attention. And my Makita palm router just wasn't keeping up with what I needed to be able to do. So I finally made the upgrade that several of you have been telling me that I needed to make. And now, after giving it a shot, trying it out, and really putting it to the test, I'm going to tell you what I really think. If you've watched this channel for any length of time, you'll know that I started my woodworking journey a little over 2 years ago and have gone from creating just a simple, occasional project to having a hard time keeping up with the orders that are rolling in. And a large amount of that business and that money comes directly from my Onefinity CNC. So I took your advice and I upgraded from a simple Makita palm router to a CNC spindle. And so now we're going to check it out today and see how it performs, and look at the one feature that changes everything. Now, before we go any further, I do want you to know that I'm not formally affiliated or employed with Pwn CNC. I did reach out to them and ask them if they wanted to send me some equipment for me to evaluate and use in my shop. So thank you very much, Pwn CNC, for that. There are affiliate links down below if you're interested in checking out any of this equipment that we're talking about. So this video is not necessarily a Pwn CNC video. It's just a video about upgrading to a spindle from a palm router. Now, depending on your configuration and what kind of CNC you have and how it's set up, you may have to make a couple of adjustments. For example, I had to upgrade to the Z20 slider from Onefinity in order to handle this 80mm spindle. Now, first of all, what is a spindle and how is it different from a palm router? Comparing a spindle and a palm router is really an unfair comparison because outside of the fact that they do this, really fast, there's not much more in common between the two. Now, they can both be used on a CNC router, but that's really where the direct comparison ends. A palm router is a general purpose woodworking tool that has a great place in any woodworking shop. And for somebody who's a starter on a CNC, a palm router is a good, inexpensive starting piece of equipment to help you learn how to use your CNC and make some awesome projects. But if you want to take it past the point of just being a hobbyist and really start making money with a CNC, then a palm router might not cut it for you. So keep in mind, I'm not down talking a palm router at all because they're great and they serve a purpose. But in most full-time woodworking shops or CNC shops, a palm router like the Makita that I used is simply not going to be able to keep up and it's going to wear out. Palm routers just aren't intended to be run for several hours at a time. Now, a palm router is inexpensive, cheap enough to replace if needed, and it's a great entry-level router for getting things up and running for many CNCs. However, upgrading to a spindle is definitely an upgrade, especially one feature that I hadn't even considered until I actually got this system up and running. So let's take a look at my choice of spindles, the Pwn CNC 1.5 kilowatt, 110 volt spindle. As of right now, I only have 20 amp breakers in my shop, so I'm not able to go with the 220. Also, I went with the air-cooled system, and we'll talk about that more in just a minute. So what are the advantages of using a spindle over a palm router? One of the biggest selling points of a spindle is the decreased noise. Now, when you really think about it, you typically have dust collector going, the noise from your spindle or your router, as well as the noise from the router bit cutting into the material, all factoring into that noise. So noise caused by a CNC is really a three-headed monster. If you make the switch to a spindle, the noise from the bit as well as the noise from your dust collection won't change. So the only real advantage on the noise front, in my opinion, is the decreased noise from the router itself, which while not outrageous, is noticeably quieter. The spindle also has less run out, which is the error caused by the rotation of a router or spindle. Even though in my experience, the run out was very slight with a palm router, the run out on a spindle is less, which can help decrease the noise of the bit as well as the accuracy of your cuts. Next, the next advantage of a spindle is increased torque. Increased torque typically means that you'll be able to make heavier cuts, therefore improving productivity. But remember, you must also consider all elements of your CNC. A lower quality or a weaker CNC is probably not going to allow you to make use of that increased torque. So keep that in mind. I have more of a buy once, cry once philosophy in my wood shop. So I put more money into my 150 Woodworker X50 with the expectation that it was going to hold up over time and be a more heavy duty type of a CNC router. Now, if you'd like to see more about my experience with a Onefinity specifically, I will put an info card up there as well as a link down in the description, so feel free to check that out. Also, keep in mind the quality and the brittleness of your bits. You can't expect a 1/8 inch bit to cut through 1 inch of white oak in a single pass, no matter how strong the CNC or spindle. So keep that in mind. Spindles can typically be a little bit more aggressive, but you've got to think about the weakest part of your CNC machine, which is typically going to be the router bits themselves. Next, let's talk about collet sizes. And the collet is a little piece of metal that grips your router bit and actually holds it in place while it's cutting. With a palm router, the typical collet size is just 1/4 of an inch, and that's all that you can do. You can get a collet reducer so that you can use 1/8 inch bits, but you can't go any larger. With my particular spindle, which is an 80mm ER20, the kit comes with an 1/8 inch collet, a 1/4 inch collet, which is actually on my machine right now, and I'm also able to use a 1/2 inch collet if I wanted to use bigger bits. The next difference is that with a palm router, they are all typically going to be air cooled, which means that air is simply going to flow through the palm router to cool the motor down. With a spindle, you can get either air cooled or water cooled. Now, I'm not going to weigh in too much on this one because I chose to stay with the air cooled system. From the little bit of research that I'd done, I didn't like the idea of the extra maintenance and hoses that were necessary for a liquid cooled system, so I chose to simply stay with the air cooled. Now, other advantages of using a spindle over a palm router is the fact that they are designed to last longer and to run for longer periods of time. Spindles are specifically designed to be able to run all day long if that's what you need. Whereas a palm router is typically used in short bursts and is not really designed to go all day long and be a workhorse. So those are the advantages. Now, what about some of the disadvantages of using a spindle? First of all, they're bigger and they're heavier. I find that when my CNC is actually turned off, that the weight of the spindle will actually cause the Z-axis to drop just a little bit. 1/2 inch, it's not a big deal, but that's something that never happened with a palm router. Also, they can cost significantly more, 3 to 4 times more than just simply using a palm router. So they are a significant upgrade at a fairly significant cost. All right, now that we've talked about the spindle itself, let's take a look at a couple of upgrades that really make a huge difference between a palm router and a spindle. The first one is pretty simple. It's Pwn CNC's dust boot, which is designed much differently than the Sucket dust boot that I purchased for my Onefinity. Several of the pieces are pretty obviously 3D printed, which is fine, and it's definitely larger than my previous boot, which was about ready to fall apart. One thing that I like about their version is that both the hose attachment and the brush itself are both held on by magnets, making both sides easy to remove. Unlike my Onefinity boot, which was held on by a clamp, you can easily remove the hose for a quick cleanup. They also sell a separate magnetic brush guard that you can pop onto the hose to help with cleanup at the end of a cut. And that is a big deal for me. I love the fact that I can just simply remove the hose and then clean up when the project is done with its cut. Now, my only concern is that, as you'll see right here, the brush itself is 2 inches long. And the only problem that I see with this is that if you're not careful and have the boot installed too low on your spindle, I could see the possibility of the brush getting bound up in the rotating bit. It's not happened to me, but just be sure to check that when you're adding your boot. That's very important, and I could see that possibly being an issue. And finally, this is what sold me on upgrading to a spindle. The VFD, or variable frequency drive. Whereas a palm router has a little wheel to adjust the speed, the VFD is a separate piece of equipment that accomplishes a similar task, but with some great advantages. When you create your toolpaths in your CAM software, the G-code includes speeds for your spindle. The palm router requires you to adjust that speed manually using this wheel. However, a VFD provides power and speeds to the spindle. Now, you can operate it manually, but the huge advantage of a VFD is auto mode, which automatically starts your spindle when you hit play on your CNC controller and brings it up to the correct speed. That's a game changer for me because I know that my spindle is always going to be moving at the proper speed, and as soon as I hit play on my controller, I know that my spindle is going to come up to speed on its own. That means no more broken bits because some idiot forgot to turn on his palm router, which has happened on more than one occasion. So I hope you've gotten something useful out of this, and if so, I'd appreciate it if you hit that like button down below, and if you feel I've earned it, I'd love to have your subscription as well. And if you're interested in checking out Pwn CNC's products, I've placed some links down in the description. So let's get out there and make some stuff. Hey folks, Damien from Southpaw Designs. And today we're going to take a look at one way that you can separate yourself from your competition. and that's learning to master the art of the inlay. Now, several months ago, I posted my first inlay video, and it's been very successful. I'll link it down below. But today, we're actually going to look at two different ways to create inlays using your CNC. The first way that you'll see right here is very simple and easy to do. The second way that you'll see right here is a little bit more complicated, but it will allow you to do things that you cannot do using this method. So stick around and see both of them in action and really learn how to up your game on your CNC. To begin with, let's begin with the easy inlay. Now, this is going to use a fairly simple letter. I did choose a font called Homestead, which does have some sharp 90-degree corners right here, and that's going to cause us a small problem if we really want to get in those corners. The font that I'm using is called Homestead, and so once I've created this simple letter, you can go with something more advanced if you like. We're going to come over here and take a look at our tool paths. Now, I'm not going to go into extreme detail about everything. What I would rather do is place a link in the description below to a video, a great video done by Greg's Garage that actually explains how to do this using a V-bit. I'm just going to talk about how we would do these two different types. He did an excellent job of explaining it, and if I were to try to go into those details, I would basically be stealing his thunder, so I'd rather give him the credit. All right, so now how do we do this? All we really have to do is take our shape and create both a male and a female inlay. I'm going to continue to call it male and female just because I know it's going to make somebody mad, and that makes me laugh. So we select that, and then we can either use both a profile and a pocket, or we can use the inlay toolpath. Now, I prefer to use the inlay toolpath because the inlay toolpath is going to recognize that whichever bit you use is not going to be able to get into those sharp corners. And so it's going to make a concession and adjust that on both the female and the male. Because these interior angles, your bit would not be able to get into that corner because it is a round bit. All right, so that's just a simple explanation of what's going on here. So now let's jump over to the CNC and actually create this. So now that we have our wood prepped, this is going to be a 1/4 of an inch thick piece of walnut, and that's just a piece of pine right there. In fact, this is an old fence picket that I just cleaned up and planed down. I'm going to use the simple CA glue and tape method, or you can use double-side tape if you happen to have it in your shop. And the first thing that we're going to cut out is going to be our male or our plug. Now I've sped this process up. And we'll go ahead and jump to the finish here. Now I should have gone about another, 32nd of an inch deeper to get rid of these little burrs, but I can easily clean those up with a quick little sanding. All right, and now let's go ahead and cut the, I just said go ahead again. Now let's cut the female, which is going to be our pocket. Nothing really radical here, although I should have used a downcut bit instead of an upcut bit. That would have gotten rid of those burrs right there. I'm going blind and I can't see the difference between the two. All right, now that we have it cut out and cleaned up, all that we really have to do is pop those two pieces in there. Now this one actually ended up fitting much better than I thought it would, and once I popped it in, I couldn't get it back out, so I didn't even have a chance to glue it. Now, if you take a look right here, you'll notice that those curves are not nearly as tight as they should be because of the roundness of the bit. So that's method one, and while it works, it could be a little bit better. Now let's move on to method number 2. And if you've made it this far, I do appreciate it. I would appreciate it also if you'd hit the like button down below, subscribe if you haven't, and then always leave a comment. I'd love to hear back from you. Okay, so let's take a look at method 2. Now for method number 2, this is going to use a V-bit. And once again, I'm not going to go over incredible details in V-Carve Pro because I think Greg's Garage does a better job, does an excellent job of doing that. I encourage you to watch that if you'd like to learn more. But we will need to have 2 different versions because the positive and the negative, or the male and the female, has to be 2 different files. This would actually be the plug or the male side, and it's actually going to be a reverse of the female. So it's going to actually be a mirror image and backwards because we're going to press the two pieces together. All right. Now for this, I did use two tool paths. One was a clear because we have to get rid of this stuff right around here. Otherwise, we won't be able to press it down into the female pocket that's created. I did them as separate tool paths because you do require a tool change. Then we have the V bit right here, which is going to make a V-bit path that allows us to press it in. Now let's take a look at the female side, which is really just going to be a V-bit toolpath. So, oops, let me close that. I've already got it created, and if we take a look at it, we see that it is a V-carve, and let's preview it. And these are the results. So this is going to be the female side, and the male side is going to fit down inside of it. When we examine the toolpath, you'll see that we have a start depth of 0.1 inches and a flat depth of 0.1 inches. And we're also using our 60-degree V-bit. Again, Greg explains it much better in the Greg's Garage video, but I wanted you to see what's actually going on here. So next we'll go to our CNC. My CNC of choice is the Onefinity Woodworker X50. I always like to use the X, Y, and Z probe. And once we have that, and I am going to skip through a bunch of this because this takes a long time, but I have my V-bit cutting out my pocket for my female side. Now, like I said, I'm going to speed this up and just show you a bit of the highlights, but we can see it from the beginning, the middle, and then now we're finishing everything up. And let's take it off of our spoil board and take a look at it. It looks nice and clean. I like that. Once we have the pocket done, now we're going to switch over to our male side or our plug. Also going to use the V-bit to cut everything out. And just as I did before, I'll speed through a lot of these different sections. Now, I did dodge a bullet right there. When I made my square that I actually have to cut out, you'll see how close I got to that nail. When I realized how close I had become, I about dirtied, soiled my pants. But thankfully, I was within about a 32nd of an inch of hitting that nail. So you'll notice I get rid of it as soon as I can, as soon as the CNC's moved out of the way and I can take that nail out. Once we have the V-bit done, now we're going to clear out the rest of the pocket. Now, you don't necessarily have to do this if you want to take it to your bandsaw and scroll saw and cut it out, but I would just rather cut out as much of it as I can. It did take a little bit too long, so I could have been much more aggressive with getting rid of this, but it took a little while. And now that we're finally finished, let's remove it from our spoil board. Take a look at them side by side, and they look great. So let's actually see what happens. Let's go to our bandsaw and cut off those extra pieces. Because remember, since this is going to be a plug, it needs to be able to fit down inside. And it's not going to fit down inside with those extra pieces on the end. Next step is to fill it with glue. Now you always want to make sure you have a little bit of space in that pocket so that you can put plenty of glue in there so that it will have room for that glue to hold. I put way too much in, so I'll wipe some of this away. Then we press it down and clamp it up. Once we're completely clamped, we let it dry, then we come back over to our bandsaw. Don't make fun of me here, I'm still learning how to use my bandsaw. It's a new investment. And we're going to cut off that extra piece. Now, I take it over to my spindle sander and I try to get rid of as much of that part that's still sticking up as possible using a 60-bit grain. And once we have that done, then I'll move over to my random orbit sander and I'll finish it up with a 120 and a 220 grit. Now that everything's cleaned off and nice and flat, I'm going to use some Odie's oil. I like Odie's oil. It's natural, it smells nice, and it really brings out some of the great color there. It's expensive, but a little bit goes a long way. I highly recommend it. Now let's take a look at the two of them side by side. Both of them look nice, but there's an obvious difference between the simple one done with the simpler method and the more advanced one done with the V-bit method. And I like that much better. Hey, next week I'm going to be going out and doing some lumber shopping. I'm going to go to Woodcraft and pick up some kind of crafty pieces, as well as going to my local lumber yard. So in the comments below, tell me what particular species of wood that you guys like the most for the different types of projects that you create. Does a CNC belong in a woodworker's shop? Ladies and gentlemen, today we're going to tackle that question. Can a CNC replace other tools like a drill press, planer, jointer, router table? But more importantly, if it can accomplish these things, does it do a good job, and is it a reasonable substitute for those other types of woodworking tools? Now, if you're immediately triggered by this video and you're ready to choke me through the screen right now, all that I ask for you to do is hang back for a few minutes, because we're going to try some things out. The results may be good, they may be bad, and I'm not going to try to sugarcoat anything. I'm a CNC enthusiast, but I'm also a woodworker, and I want to see what works and what doesn't. So I've got one rule. Before you start spamming me in the comments and reporting me at the next man club meeting, at least hear me out. Let's see what happens. Let's see what works and what doesn't. So our first task is going to see how a CNC can actually joint boards. Now, keep in mind that if you need to joint long boards for a tabletop or cabinets or anything like that, a CNC is probably not going to be a good choice, just simply because of the size of it. In my shop, I mostly make small projects, decor, and that kind of thing. So I wanted to see how it would do with jointing a 12-inch piece of material. So let's go ahead and jump right in. Okay, the two pieces of material that I'm using are white oak and a little purple heart. Don't use purple heart that much, but I picked up some from Woodcraft. And what's funny is once I planed it down, it actually looks more brown than purple. Tends to do that as it dries out and ages. So I'm just using a simple 1/4-inch downcut bit, and I'm just getting a straight edge here. That's all that we're doing. Once we have that, let's just put it together face to face and see what happens. And it looks really nice. You know, CNC is computerized. It's meant to be accurate. And guess what? It surely is. So when we take a look at this board, it does appear that a CNC does a great job of jointing small boards together. But I want to see what it looks like when it's glued up. So let's just do a simple glue up. Now, I'm not worried about putting calls on it because this really is just a test. So I'm going to use a couple of my smaller clamps and just clamp it together and see how it does. When I'm finished, I'll sand it off and see if we can make it nice and even, because I'll end up using this wood for something. Okay, so now let's let those boards dry. And while we're waiting on that to dry, let's shift gears and see if we can use a CNC to replace a thickness planer. Now, thickness planers reduce the thickness of your board, but they can also be used in certain situations to remove cups and bows. So we're really going to try and see if we can use that CNC, and specifically a 1-inch surfacing bit, to remove a bow from a board. Now, I'll leave a link to the surfacing bit that I use down in the description below. I've used this method before, and it's fairly reliable. You can also use a planer if you'd like to take out cups and bows on smaller pieces. Doesn't work that well with warped wood unless you create a planer sled, which that's a whole other animal that we're not worried about right now. So this surfacing bit does seem to be doing the job. You'll notice that I did countersink the screws. Make sure that those screws are countersunk way down so that your bit doesn't hit them. All right, we use a level, and it seems to be in really good shape. So with that, I'm just going to pull out the old handy-dandy Black & Decker sander, and I'm going to sand this off to get rid of some of those burn marks, which aren't extreme, but there are a couple of burn marks on there. Now, what are my thoughts on using your CNC to remove cups, bows, or using it as a thickness planer? Personally, as a thickness planer, I would rather use my planer. I have a DeWalt 735, and I prefer to actually use it. It's much faster. It's much more efficient. However, a CNC with a surfacing bit can be used to easily get rid of cups and bows. So I think that is a worthwhile use right there. From there, let's just look at a couple of utility uses for your CNC. And one great one that I actually really do like is using it to create plugs. Just hold on to old scrap pieces. You can secure them down with double-sided tape or CA glue and painter's tape and just create plugs as you need them. I'm going to move over to my cheap AF bandsaw that I've never quite gotten calibrated correctly. And let's cut out these little plugs. All right, once we have them cut out, I just put a little glue in there. You didn't need to see that. It's wood glue. Pop them in there with a mallet and then use a flush cut saw to cut everything as even as we can. Once we have that done, I'll just use the sander and I'll sand it flat, and it looks great. All right, so this one I actually like. This is a great way to put to use scrap wood that you might otherwise throw away. Just hold on to it so that you can use it to cut plugs out of. Now, you don't have a CNC? Fine, go buy a plug cutter. You can pop it into your drill press, no problem. But if you have a CNC, you can easily make a plug file, and whenever you need some fresh plugs, just pop it on your CNC, cut out some new plugs. Okay, now why would you even consider using a CNC to create plugs when you can just as easily get dowels and use them? And there's absolutely nothing wrong with that. I do it all the time. If you're looking for a particular kind of material for your plugs, that can be difficult if you're just using dowels. Also, if you're using dowels, you're going to cut them using the end grain. So once you actually plug them in there, they have a tendency to soak up more finish, stain, anything like that, and they'll turn out darker than the material that you're trying to match it up with and cover with. Now, you can easily do what I've done and choose two different species of wood, so it isn't meant to hide it. It turns into an accent. But if you're looking for something that will match the wood grain, then instead of using an end grain dowel, cutting your plugs out of a face grain, either using a CNC or a plug cutter, can be a better solution. Okay, the next question that we're going to ask is, can we use a CNC for a typical router table? And I know it's a router, so we kind of know the answer to that, but we're going to look at a couple of options there. First of all, I would not recommend that if you were to try this, that you use a bit like this that has a pilot bearing on the end. These pilot bearings are meant to ride alongside a template or possibly the edge of your material so that when you're hand routing, it won't go in any further and you've got a natural stop right there. So if we were to try to use this in a CNC and we were slightly off, then the CNC might try to force this pilot bearing into the material, breaking the bit or possibly damaging the router or our material. So we're going to stay away from this one. But I am going to use this little cove bit and I'm going to see how it does. I really don't apply many chamfers or anything like that to most of my projects. It's just not the style that I typically work with, but I do have this cove bit, so we're going to give it a shot. So let's jump over and see how it does. Now, you do need to make sure that you get your X and Y as perfect as you can, because if it's slightly off, it could go too deep. And personally, I feel that it went a little bit too deep right here. So I'm not really a fan of using a CNC for this purpose unless you have it calibrated. So, did it work? Sure seemed to. I didn't think we'd have a problem with it, but I thought it would be an interesting thing to give a shot, and it's good to know. Now, will I probably do much edge routing using this method? Probably not. I like conventional woodworking. I like using my router, and I like finishing my projects myself. Also, there's not much room for error. If you are slightly off on your X, Y, or Z, it's possible that you could cut too deep or not deep enough. And so, in my opinion, it's just as easy to hand route these edges most of the time, but it is an option. So with that, let's head on over and see how our joinery worked out. All right, now that the glue's dried, I'll take off the clamps. Now, because I didn't use any cauls, there is a little bit of a lip on it, very slight because it's a small board. So I'll just sand it off right here. And let's take a look now that everything's nice and glued up. I will say that jointing with a CNC is a huge success. This is probably my favorite application of using a CNC for conventional woodworking purposes. Okay, so what are my thoughts on using your CNC as a jointer? In a pinch, it can do the trick. I currently don't have a joiner, and I mostly do smaller projects. So if I need a perfect jointed edge, I will use my CNC to do that. An investment in a joiner in my shop is in the near future because as I start creating larger projects, I think the CNC might have a hard time with that because my CNC is only 32 by 32 inches, which limits the size of wood that I can effectively joint. But as you saw, it did give a great finish, so there's no arguing the actual results. Okay, so what are my thoughts on using your CNC in place of a drill press and Forstner bits? It can actually be very handy because you can perfectly space out your holes by creating a CNC project. Also, you don't have to have specific size bits because you can easily use your CNC and make the diameter of those holes any size that you like. Now, you will want to make sure that if you are making, for example, a 1/4 inch hole and you're using a 1/4 inch bit, that bit's an upcut bit. If it's a downcut bit, it pushes the material down into the pocket and there's no place for it to escape. So it basically catches on fire. You don't want that to happen. So always make sure to use an upcut bit if you're using your CNC as a drill press. And since you're still here, you're probably interested in CNC related content. So check out this video right here. It is a 15-month review of my Onefinity Woodworker X50. I have zero relationship with Onefinity. It's not sponsored at all. This is just what I think about it 15 months after I bought it and put it to use. Hey folks, Damien with Southpaw Designs, and today we are going to learn all about using a touch probe and probing your CNC for the X, Y, and Z. In addition, we're also going to try out a little experiment. We're going to see if we can manually set the X, Y, and Z and get an accurate cut without actually using a probe. And we're going to kind of weigh the pros and cons of it a little bit. So stick around, hope you enjoy. And if you have any questions, please leave them in the comments below. And if you have any words of wisdom, also leave those down in the comments below. Because as I tell everybody, I'm still learning, I'm trying new things out, and I want to hear your experience because a lot of you guys have a lot more experience than I do. Okay, so as we are setting up our material, notice that we have a width of 9 inches. We have a height of 4.5 inches and a thickness of 0.5 inches. Now, the material that I'm actually going to use is going to be 3/4 of an inch, so it won't cut all the way through, and I'm fine with that for these testing purposes. Also notice that the 0 position is the material surface. That's important when you're setting up your probe. And notice that the X and Y is set to this bottom left-hand corner, which we will see when we actually go to the CNC and actually perform our XYZ probe. Now, make sure that you measure the thickness of your material. This is 3/4 inch plywood, but as you can see, it's actually only 0.73 inches, and you always want to be aware of that. Now we're going to go ahead and adhere this to the spoil board. And next, make sure that you move your dust boot connectors out of the way. It's very easy to leave those in the way and end up snapping those off. Okay, now a couple of things to keep in mind when you're probing here. It's very important to pay attention to your increments because especially when you're setting your Z, and you get it right over top here. I like to get it as close as I can. It just goes quicker. Well, if you have your increment set to half of I believe that's set to centimeters, half of a centimeter, and you're already really close, and you hit it, it's going to go right into this probe. And this is a machine. It does what you tell it to. I've snapped a couple of smaller bits before because I wasn't paying attention to my increments. So be very careful when you're setting up that probe. Don't accidentally, I've got these big fat beefy fingers, hit the wrong increment and then move it down, because what's likely to happen is you can snap a bit, you can really do some damage to your machine. So be very careful with that. All right, so let's go ahead and get it in position here. We need to put it up in that top right hand corner of our probe. There is a little circle there to show you approximately where it needs to go. Now we're going to hit the probe XYZ button, and we have to actually touch the probe to our bit. Then it will say confirm, ready to go. We confirm the size bit. I'm using a 1/4 inch bit. Click set, and it takes off and does its thing here. So you will notice that it's going pretty quickly right here, and I have sped this up. It takes about a minute and a half to actually perform the entire process, and it will probe the Z first, then it comes over to the right and will probe the, I guess that would be the X, and then it does the Y right there, and we're good. It'll say complete. You click OK, and we're done. Okay, so what we see here is that now that we have probed the X, Y, and Z, I'm going to go ahead and remove the probe. We see that the tip of the router is right there on that front corner. So it recognizes the front left-hand corner of your material. Now, there's no requirement that you set it to the front left-hand corner. You can set it to the center. You can set it to any other corner. I typically set it to the front left-hand side unless I have a reason not to. Okay, so is it really necessary to actually use a touch probe, or can you manually set it yourself? Now, I'm going to come right out and say that I would recommend that you actually invest in a touch probe. I think it's going to save you more time, more hassle in the long run, and it only takes one failure up here to break a bit, then you've wasted 20, 30 bucks or more, and you could actually damage more of it. But let's give it a shot and actually see what happens. So what I'm going to do is I'm going to go ahead and I'm going to manually try to set this, and then we're going to run it and see what happens. Now, I'm going to watch it very closely because this is an experiment, and the goal is not to create a finished piece here. The goal is really just to test and see what happens. So let's go ahead and position it. So I'm going to go ahead. I've already got the X and Y positioned right there, but I'm going to come down and I'm going to position the Z, and I want to be very precise. So I'm moving at 0.05 centimeters at a time. Now that's really, really close. I'm going to go to 0.005, and I think that's about as good as we're going to get. So now I'm going to set that as my Z. So there's the 0 right there. So I'm set to 0, 0, 0 for the X, Y, and Z. Now I'm going to back it off just a little bit, move it up there. And I've already got a coaster loaded. It's just a simple circle design. that I do quite a bit. So I know exactly what it's supposed to look like. It's going to be about a 4-inch coaster that's got a little pocket right there in the middle. So let's go ahead and hit start and see what happens. Okay, so we're going to let it run here. I have not edited this. I'm going to let you see the entire project from start to finish, but I have sped it up to about, I believe it's 800% speed. So we're going to see this entire cut in less than a minute. But since we are performing an experiment here, I do think that it's important that we actually see the entire project from start to finish so we can see what the finished work looks like. Now, you will notice a lot of burrs. I'm using an upcut bit right here. I should really be using a downcut bit, but no big deal. So now we're actually going to do the cutout. You'll notice that it does not go all the way through to the bottom of the board because this is a 1/2 inch project and I'm using a 3/4 inch piece of material. Okay, so we're all done. So let's go ahead and move it out of the way. Okay, so now let's take a look right here. Now, I know what this particular file should look like because this is a simple coaster file. I make them all the time. In fact, I've got a couple of other videos where I show you how to actually do these. So let's go ahead and remove it. And let's take a look. Now, it didn't cut all the way through. That's fine. That's not a mistake. This file is only 1/2 inch. Yet this board, this is 3/4 inch plywood, so I measured it and it's actually 0.72, 0.73 inches. So I didn't expect it to cut all the way through. What I did want to see is how did it do with actually cutting it out using a manually probed X, Y, and Z in this front corner. And as you can see, it actually did a really good job. Knowing what this file should look like, this actually turned out really well by manually probing it with the X, Y, and Z. It's got about 0.2 inches right there that you can see, and it cut out both of them really well. So in a simple project like this that I've cut over and over and over again, I really can say that I don't feel that it's a big deal to manually probe it. Now that said, I don't think I really encourage it because if you were doing something that was more precise or that potentially you had multiple tool changes on the same piece, which most work pieces are going to involve a level of complexity that's higher level than this, you're going to want that accuracy. So even though we see that you still can manually set your X, Y, and Z, I don't know if I really recommend that. So let's do one other thing right here. Now this should be 1/2 inch. So let's grab our calipers and let's see how deep it actually did cut right there. All right, so I'm gonna manually try to line that up there. And it looks like I got 0.49 inches. So if I was off about 1/100th of an inch, which I can handle that for something as imprecise as this. And for those of you guys that watch my videos, those of you who've subscribed, I want to say thank you. I crossed over the 2,000 subscriber mark this week, and I'm happy to say that I reached the goal. For many of you who follow this channel, you know that I'm a high school teacher, and the original start of this particular channel was an experiment that I did with my promotional media class. So school got out yesterday, and I crossed over 2,000 subscribers and was able to get monetized and show those kids that it is something that can happen. So I want to say thank you guys for all the support. And I've taken a couple of weeks off just to kind of regroup a little bit, and I'm looking forward to moving forward. So thank you guys for everything, and comment below and let me know what types of videos you'd like to see. I appreciate all of you, and thank you. Oh, wow, you made it to the end. That's really impressive. Since you're still here, make sure to check out this video right here, which is one of my most successful CNC projects ever. And it's something that you can create on your own with a variety of different CNCs. So go check it out.